Delving deeper into memory organization. Memory organization is the intricate architecture behind how computers store and retrieve data. This in-depth guide will explore its key concepts with real-world examples to enhance your understanding. The building blocks of memory. Bits. The fundamental unit of information in a computer. A bit can be either a 0 or a 1. Imagine a light switch, either on 1 or off 0. Bytes. A group of 8 bits typically represents a single character like a letter, number, or symbol. Think of a byte as a single word you can write with 8 letters, zeros and ones. Words. A group of bytes that the CPU can process at once. Word size varies depending on the processor architecture, often 2 or 4 bytes. Imagine a word as a short phrase made up of a few bytes, groups of 8 letters. Address. A unique identifier, like a house number, assigned to each memory location. The CPU uses addresses to locate specific data within the vast memory space. Memory characteristics. Capacity, measured in bytes KB, MB, GB, TB. It represents the total amount of data memory can hold. Think of it as the total storage space in your filing cabinet. A typical computer might have 8 GB of RAM main memory. Speed, measured in nanoseconds ns, it signifies how fast data can be accessed from memory. Faster memory allows for quicker program execution. Imagine being able to find a document instantly in your filing cabinet compared to having to search for minutes. RAM is much faster nanosecond than a hard drive milliseconds. Volatility. This refers to whether data is retained when the power is off. Volatile memory RAM loses its contents when power is lost, like a whiteboard where information is erased when you turn off the lights. Non-volatile memory ROM retains data permanently, like a written document in a folder. The memory hierarchy. Balancing needs. Computers employ a tiered memory hierarchy to achieve a balance between speed, capacity, and cost. Cache, a very fast, small memory located within the CPU. It stores frequently accessed data for immediate retrieval, significantly reducing access time. Imagine having a small tray on your desk to hold the documents you're currently working on for quick reference. Main memory RAM. This is faster than secondary storage and holds data that the CPU is actively using. It's volatile, so data is lost on power off. Think of RAM as your active workspace on your desk where you can manipulate documents. Auxiliary memory. Secondary storage. This provides much larger storage capacities but has slower access times. It's non-volatile, so data persists even when powered off. Imagine auxiliary memory as file cabinets in your room where you store less frequently used documents for long-term access. Examples include hard disk drives HDDs and solid-state drives SSDs. Main memory RAM. The workhorse, directly accessible by the CPU for program execution and data manipulation. Volatile, so data is lost when powered off. Imagine leaving your work on your desk overnight. It's gone when you return power off. Capacity typically ranges from a few gigabytes to tens of gigabytes, sufficient for running programs and manipulating data in use. Auxiliary memory. Secondary storage. The archive. Slower access times compared to RAM, impacting program loading and file retrieval speed. Non-volatile. Data persists even when powered off. Imagine your documents safely stored in a file cabinet, ready to be accessed when needed. offers significantly larger capacities, terabytes and beyond, for storing vast amounts of data like movies, music, documents, and applications.
Examples include hard disk drives. HDDs utilize magnetic platters to store data. They are relatively inexpensive but have slower access times and are more susceptible to physical damage. Solid-state drives. SSDs employ flash memory chips for data storage. They are faster, more durable, but generally more expensive than HDDs. In conclusion, understanding memory organization empowers you to appreciate how computers efficiently manage information. The memory hierarchy ensures that frequently used data is readily available while providing ample storage for long-term needs. This intricate system is the foundation for seamless program execution and data manipulation on your computer. Multiple choice questions on memory organization with solutions and explanations. Instructions. Choose the best answer for each question. Question. The most fundamental unit of information in a computer is called a byte. B word C bit D address. The correct option is C. Explanation. A bit is the basic unit of information, representing either a 0 or 1. Bytes, words, and addresses are built upon combinations of bits. Question. How many bits typically make up a single character? A 2B4 C8 D16. The correct option is C. Explanation. In most modern computers, a byte consists of 8 bits and is used to represent a single character. Question. In the context of memory, what does volatility refer to? A. The size of the memory. B. The speed of data access. C. Whether data is retained when powered off. D. The type of data being stored. The correct option is C. Explanation. Volatility refers to whether data is lost when the power is turned off. RAM is volatile, while ROM is non-volatile. Question. Which of the following memory types is the fastest but has the smallest capacity? A RAM. This is correct option. B. Hard disk drive. HDD. C. Solid state drive. SSD. Cache. This is the correct option. The correct option is D. Explanation. Cache memory is the fastest type but has the smallest capacity. RAM is faster than HDD and SSD but slower than cache. Solid-state drives. SSDs are generally considered faster than hard question disk drives. HDDs because A. They use magnetic platters for storage. B. They have moving parts that can slow down access. C. They rely on flash memory chips for faster access times. D. They are more susceptible to physical damage. The correct option is C. Explanation. HDDs use spinning platters for data storage, introducing mechanical delays. SSDs utilize flash memory for faster electronic access. Question. A unique identifier assigned to each memory location to locate specific data is called a byte. B word C address. D cache. The correct option is C. Explanation. An address acts like a unique label for each memory location, allowing the CPU to find specific data. Question. Which of the following best represents the role of cache memory in the memory hierarchy? A long-term storage of large files. B. Storing frequently accessed data for quick retrieval. C. Holding the operating system for execution D. Providing additional storage space for RAM. The correct option is B. Explanation. Cache memory stores frequently used data for faster access by the CPU, reducing the need to access slower main memory RAM.